Hi Year 12. This is the first in a series of videos for the topic Statistical Analysis for Extension 1 Mathematics. So in this topic, we're going to look at Bernoulli random variables, binomial distribution, mean and variance, normal approximation to a binomial, and sample proportions. So let's start with Bernoulli random variables. A Bernoulli random variable is a discrete random variable where there are only two outcomes, success or failure. Now remember, discrete means whole numbers, and in this case, they're going to be 0 or 1. 0 for failure, 1 for success. A typical example is tossing a coin and recording the number of tails. And in this case, we could make tails equal to 1, that's success, and heads or no tails equal to 0. Now, in a table, you can see here we have our random variable, and here are the possibilities, 0 or 1, and here are the probabilities. And in this case, it is a uniform distribution because all the probabilities are equal. Now, I mentioned that a Bernoulli random variable can only have two outcomes, but the sample space of the experiment could have more than two outcomes. So we looked at this one before when we toss a coin. Now, with a coin toss, there are only two outcomes, heads or tails. And in this case, we say, if it lands tails, this is considered a success. If it lands heads, then that's a failure. But how about a six-sided die? When we write the sample space for this, there are 6 outcomes. So somehow we need to reduce it just to 2. So we could say, if a 6 appears, this is considered a success. If it doesn't appear, then that's a failure. And let's try one more. A counter is chosen from a bag containing red, blue, or green counters. If we choose a green, that is considered success. If we don't choose a green, that is considered failure. Recall the mean or expected value of a discrete random variable is given by this formula here. So we multiply the outcome by its probability and we add them all up. There's only going to be 2 in this case. So we've got the probability of failure multiplied by 0 plus the probability of success multiplied by 1. That's always going to be equal to 0, so this is equal to P of 1, which is just the probability of success. Here's an example. What is the expected value for this Bernoulli distribution? So we can see the chance of failure is 3/4 and the chance of success is 1/4. We can go 0 times 3/4 plus 1 times 1/4, or we can just use what we just figured out. The probability of success is 1/4, and that is the expected value. Recall the variance of a discrete random variable is given by this formula here. So we're going to do this for x is equal to 0 and then x is equal to 1. And remember, e of x is p. So substituting in, we get 0 take p all squared, p of 0, plus 1 take p all squared, p of 1. All right, tidying that up. This is p squared. Now, p of 0 is the same as 1 minus p. Does that make sense to you? Because this is the probability of failure. Remember, probability of failure plus probability of success must equal 1. So the probability of failure is 1 minus p. Expanding that out, 1 minus 2p plus p squared, and p of 1 is the probability of success. That's p. Tidying this all up, we get our formula p multiplied by 1 minus p. So let's work out the variance for this example. Remember, p is equal to 1/4. Here's our formula, so it's going to be 1/4 multiplied by 1 minus 1/4, which is 3/16. Here's example 2. An experiment has the probability of success equal to 75%. Write a piecewise function to describe this distribution. So remember, a piecewise function is going to look like this. It's going to have this curly bracket. And we're going to have 2 statements here, one for success and one for failure. So probability of success is 75%. And remember, success is 1. And failure is going to be 25%, and x will equal 0. Now, a single Bernoulli trial is not particularly useful, but when multiple Bernoulli trials are performed, we have a binomial distribution. And here's the properties of a binomial distribution. It has a fixed number of trials, so we might toss a coin 20 times. Each trial has only two outcomes, success or failure. Each trial is independent, so if I toss a coin, it's not going to affect the outcome of the second toss. And the probabilities stay the same. So if the probability of success is 3/4 in the first trial, it has to be 3/4 for every trial. So let's consider the Bernoulli distribution below. We have probability of success of 75%, probability of failure 25%. 3 trials are conducted. Find the probability that there are exactly 2 successes. Now, back when you were learning about probability in Year 11, you would have drawn a tree diagram for this. And if we want exactly 2 successes, there are 3 ways we can get that. We can have success, success, failure, or we can have success, failure, success, or we can have failure, success, success. Or in other words, those. Now let's just multiply those probabilities together. I'll just put it up on the screen and talk you through it. So probability of 2 successes, we're going to have success times failure plus success times failure times success plus failure times success times success. And so the probability is 42.19%. Okay, that's it for this lesson. Our next lesson, we're going to look further into binomial distributions.